Hello.
And I will share the slides again now.
Okay, I have also started the stream, so
With
we
this,
are actually live.
oh, okay. Uh,
Yeah, I have also added you, Piyush, to the stream. So,
okay. Wait, before you do that, I just want to make sure that. Oh, the slide
yep, sure.
takes a while to process.
Yep. So, before we start, I will just start with a small introduction. Welcome everyone for the webinar Uncovering High Cardinality with Piyush Verma. Piyush is CTO at Last9. And in terms of monitoring and observability, we often hear these terms samples, cardinality, time series. But why they are important and how they play a very important role, even crucial role at times in understanding the health of our system is extremely important. And sometimes, if you haven't uh, understood the cardinality properly and its significance, it can cripple you at the time of understanding the problems that are happening in your system. So it's important to understand cardinality, its significance, and how you can address handling high cardinality at scale. So today, Piyush will be sharing that with us, and with that, Piyush, I will hand it over to you. You can share your screen and then we can move forward.
It's already shared. I think you'll have to present. Yeah.
Yes, I
Cool.
have added it to the stream, so it's visible.
Cool. Superb. Uh, Whenever we speak of higher observability, because this cardinality is in the realm of it, we always keep talking about the three pillars of observability. I mean, it's inevitable to run that into those three things when you're trying to read something on the internet. And we say their logs, their metrics, and their traces. We kind of abuse them by now. This is all we know of at the surface level of it. The While we speak today, we're going to dissect, go layer by layer into specifically the metric section of it. And they're very important and very powerful. The talk by no mean I mean to say that logs and traces are not relevant, but they are for a separate set of audience. I want to double down on how and why metrics are actually very important to begin with as well. And sometimes we do not value the real insights and the power they can log, and that's primarily because of the limiting nature of how metrics have been. We have this fear of there's only so much data that they can keep. They're only for infrastructure monitoring, etc. So I'm gonna go take all of these things that these beliefs that we have, and go one by one layer deeper into how can we really start embracing them. And at what point does a friction come in to say, oh, I can't use it any further because of this problem called cardinality? Anyway, so first up, I mean, there's no logs versus metrics versus traces. There are logs and metrics and traces. It's not that one of the other is better as an observability signal than the others. I mean, they all serve different purposes. But let's talk about what are these things that metrics do that usually you won't be able to do with logs and traces. And this is where having a separate focus, like a focus effort towards metrics is very important. More than logs and traces, I think metrics have the capacity, by the virtue of their data type, to be saved for a very long period and be saved at very high entropy and velocity of data as well. And they end up unlocking a bunch of these features, which is aggregated analysis. You can look at something and say, oh, here's a problem, because you can actually fold them up to make any quick assessment about where a problem could be. They help you do capacity planning as well. I mean, how do you do capacity planning with logs? It's always done with metrics, or you do service level analysis. You don't use a log line to say that is 95% up or 95% down, right? That is done using metrics itself. Any long term trend, any chart that you plot is actually just a metric, right? Or any planning and forecasting that you may have to do. Okay, next year I may need this graph is going up, so I may need 3x of infrastructure or 2x of infrastructure. Like you use these metrics to actually unlock all of this. Let's go dive further into this. What do you mean by aggregated analysis? Aggregated analysis could be comparisons. Infrastructure A, infrastructure B. I've done a canary. Now I want to make sure that is my really rollout looking good or not? This I can only do when I do at a high level, right? I can't take a summation of 1 million requests, then try to look at each one of them. I'll have to do some sort of aggregated assessment of, is this better or is this not better? This comparison is only done using them. Finding bottlenecks. I got an architecture diagram and I see, load balancer is the one where I see latency dropping. Or I say, no, it's not the load balancer. It's maybe the Nginx behind it, or is the application behind it. Finding these quick bottlenecks are done using logs in metrics itself. Or if I have to find the questions like, what was the average response time last week, or average response time this week? Or what was the peak throughput served? Like last deployment that we did on version 1.3.8 that we had, or 1.2.5 did we have? What was the throughput that we served? All of these answers require aggregation, and this is done using metrics. Or if you want to do capacity planning in terms of let's look at the max CPU utilization or max memory utilized over a period of time so that we can provision accordingly the newer set of infrastructure. Or service level analysis, uh, also called as service level indicators, things that you set SLOs and SLAs on. All of this is done using an aggregation of a certain amount of data that is defining the behavior of the software that is running, and that is done using metrics again. Or long term trends, things like how much am I consuming or how much am I wasting? What is the spend like? What is the growth looking like? Or things like planning and forecasting, which is to go basis of what you have done. Now, if I really have to go forward, what kind of scaling ladders would I require? Things that you would say, uh, well, I do see an upsurge coming. This was a beta release. The next one is a production release, or the RC one has worked well. I want a full release out of it. And this is what I need to provision. So let's say we had 10 million requests. Now we're going to look at 100 million. So all of this is done. This is the power of metrics. So all of these classes of questions, these category of questions, you invest in sending all this data as metrics, and then you done these views or these queries on top of it, which gives you a perception of the knowledge of the system itself. Now, but before we go further, what does a metric look like? It's very easy to identify a log line. Anything that you see on that black screen is a log line. Nobody has ever seen a trace, but I'll leave that apart. I want you to imagine a metric as a very smallest atomic part here. Think of it like a cube with multiple dimensions of it. One dimension holds what is it measuring. Now, let's say here we say I'm measuring CPU. There's another dimension which says what am I measuring it for. So you would say I'm measuring it for pod one. And then what is the duration for which this recording is captured? Like here it's 1 week, it could be a minute. You would say, I have observed the CPU utilization for this pod to be 40% for a duration of a minute. Now, this is the most atomic way to represent a piece of information, and this is a metric. Now, or you could see it as a flat line as well. Uh, let's say payment completed seconds, all requests that were completed within 5 to 10 milliseconds via a credit card mode for this timestamp, during this timestamp. So think about it. This is not an atomic transaction here. It's not saying that what is each request saying. No, this is an aggregation, which is the smallest aggregation that you have kept, which is for this 1 minute of period, this is the property, this is the behavior, which is the time taken to complete a request for this particular mode of payment, and all requests that land into this bucket. Now, this is how you save information. This is what a metric looks like. Now, let's dissect it further. The first part is called a name of a metric, which is what are you measuring? Here we are measuring time taken to complete a payment. What are the dimensions, which is what are you measuring it for? Now, this could be mode credit card, a bucket, and what is the reporting time? That is, what is the time at which this was reported, and then there's a value for it. Now, think about it, how this comes. As you have more and more recordings coming in, maybe metric name and dimensions don't change as much, but there's a constant influx of reported at interval, and there's a corresponding value to it. Now, as metrics grow, as your observability grows, or as your observation grows, they're going to grow in one of these dimensions. Either you start saving data for longer. So imagine you got 1 minute of recording, and you got second minute of recording, third minute of recording. So think of it like a cube expanding. You got cubes, stacking against on the horizon of time. Or you may say for the same machine, for the same duration, I will observe CPU, then I'll observe RAM, then I'll observe this, then I'll observe uptime. So it's going to stack this way. Or you may say for the same CPU, for the same time, I'm going to observe it for pod 1, pod 2, pod 3, pod 10, and so on and so forth, which is more number of things being observed. Now you pay attention. This is literally what cardinality is. This is how cardinality grows. Now let's take a few practical examples of this, right? We're measuring the payment completion second itself. And this is a good part about cardinality, and metrics as well. They only grow in one direction. What that means is as your need for these questions increase, you're going to keep adding more and more data that you want to look at. Or another way of looking at this is rather than saying that I'm going to add more data, you're basically making your questions more finer and more granular. Let's take an example here. We were measuring payment completion seconds by mode credit card for a certain bucket. Now, this is the first one, which is good. Now we will have more questions. We say, okay, great. I have found that credit card payments take up to 5 to 10 seconds, but I only want to know the successful transaction and the failed transactions to be seen as differently. So we add another label to it, which is status. The value may be 0, 1, 2, 10, whatever. Pay close attention. This is a quite a natural curiosity that will drive us towards adding this more information because we want to make our answers finer with every single attempt. Once we have made sure that, okay, we can tell very quickly that credit card payments are slow, but we want to know whether it is the good payments that are slow or the bad payments that are slow. Once we find that answer, there is further curiosity. Okay, great. At what gateway is it happening? Is it a gateway number one or a gateway number two? Because it is possible that the problem is not in our code base and maybe it is a transport level problem. So we start emitting another label, which is gateway. Great. Now, where the gateway could solve a problem for me, we have another question. What device is it? Is it that people who pay via mobile that is slow, or people who pay via the web that is slow, or people who pay via the POS system that is slow? It's a natural progression of these questions that we need to know. And with each passing question, we need more and more data. And this is how cardinality grows. Because the finer you go, the more number of possibilities and options of the data is increasing. It could also be what processor am I using? It is either whether the problem is with Amex or whether it's MasterCard or whether it is Visa. Because why is this information important? Because you want to eliminate. The purpose that these metrics solve is you want to eliminate fast. Here is not a problem. Here is not a problem. Here is not a problem. Maybe here is the problem. You're using differential analysis or rules of elimination to quickly rule out what is guaranteed to be working. So whatever is left is what we will debug further. Now let's look at slightly number way of looking at it, right? When we had only two metrics, or two labels to it, which is bucket and mode, let's say there were only two combinations. Say we classify our payment request into 20 buckets, which is 0 to 1 seconds, 1 to 5, 5 to 10. There's no golden rule to say how many buckets you should have. It just depends on how granular you want your information to be. And say there are 6 modes. The totality of this would be 120 combinations. Let's take another example. When I add status to it, there could be 8 status modes: unauthorized, void, capture, pending transaction, whatnot. Now, as I add another status of observation to it, it becomes 20 into 6 into 8, which is 960. We add another gateway to it. Let's say in production we use three gateways. I mean, that sounds fair. This number becomes 3,000. We add another device to it, different devices, iOS 13, iOS 12, iPhone this, iPhone that, Android this. This number has started reaching 25,000. We add another processor to it. There are only three kind of processors mostly out there. And very soon, this number has almost touched 100,000. So if you look at this, it's a very simple metric. This one single observation itself. And what is that observation? Is that time taken to complete a payment. That's the only observation. For any meaningful answers to be found, this number already looks 100,000. This is how cardinality will start exploding. And this is inevitable. Either we can say we do not want these answers, or we say that if we want these answers, we want a way by which we can actually stay on top of this many number of combinations. For a single metric, that was like 100K at every reporting interval. Now, this is a key part here. Remember, for every single timestamp, these many number of records will be coming in. The entire row at time t1, at time t1 plus 1 minute, at time t1 plus 2 minutes. This is on this cardinality is also called as active time series. If you have used other systems, this is also how it is referred to as. So why is cardinality relevant? Because to recap this, we want to move everything from lagging to leading information. Buzzwords, but before we get to that, it's important that we actually understand how are metrics consumed. Say, remember those cubes again? Now they're stacking up. There's data coming in all the three dimensions of more number of things to be observed, more number of uh, observations to be made, and more amount of time that the data is saved for. And then you run it using, you query it for one of the use cases, which could be one is alerting. Maybe you're constantly pulling this data for alerting, or you're building dashboards on it, which is looking at these charts to understand what's going up, what's going down, and it could be manual analysis. Or, well, you could be running a pipeline on it where it's not a human which is processing this data, but it's another system which is pulling this data from the database and then trying to understand, okay, these are the historical trends. It could be an automated system. It could be an IPython notebook as well, for that matter. But do remember, now, in all of this pursuit, we're trying to find answers. And this is why cardinality is important, because your knowledge can only be as granular as your data goes. Remember when we said, if I never saved the status, I would have never been able to answer what credit is it, the failed credit card transactions that take longer, or is it the successful ones that take longer? Because if it were the failed transactions, and with a specific reason, one of the reasons could be cart abandoned. Now, a abandoned cart is generally going to take long, right? It's going to push my latency to far up because, well, somebody abandoned it. So they didn't return for an hour. So maybe the payment took too long. Now, those are the transactions which do not suggest anything that is wrong with the system. And maybe they would have fooled us to believe that, oh, we got to invest time in debugging this. Maybe we have to spend development cycles on it. Maybe I have to develop debugging cycles into it. It all becomes irrelevant. That effort could have been saved, but only if I had that granularity of data with me. Also, actionability is directly proportional to the resolution of data. Let's take an example here. If I was to save my data, let's say only for an aggregated sum of a week, we would never be able to dissect it down because metric is the most atomic unit, which cannot be dissected further. If I only save a week worth of aggregation as the most atomic thing, then if you ask me further, does it happen on a Monday or does it happen at the lunchtime? Does it happen in the evening time? We will never be able to tell that. So actionability is directly proportional to the resolution of data that we save it at. So you're going to go as granular as possible, but that also exports the data. So it is a fair trade that you'll have to take between what is the fidelity or what's the resolution at which I have to save the data, and not go as low where it becomes so atomic, but also not as high where you cannot make any meaningful information out of it. Now, some of the real world stories, we would see that uh, And that is a trouble with all the content that we read around metrics itself. Anytime we read cardinality, we're only looking infrastructure very carefully. So far along, I've actually stayed away from infrastructure metrics because that's a very easy to imagine use case. I've been trying to pick metrics which are more related to application, business process, and etc. And here's some real world stories that we actually have worked with in where people have actually leveraged high cardinality to solve some very interesting use cases. Now, here's the first one. There's a cricket tournament at IPL that goes on. Now, one of our customers actually leverage high cardinality to measure concurrent viewers. Now, think about it. All the devices, what they do is they take their heartbeats. Each heartbeat line actually becomes a metric. Now, inside the heartbeat, they also add more stuff like what content is being watched, what is the device, where is the region and locality. Now, at so many devices, think about it. Like, the people go in like and say, come in as 40 million concurrent viewers, 50 million concurrent viewers. That much amount of devices registered against the same metric. Now, this is where cardinality is coming into play. So the metric is itself is called last seen at or something like that, uptime, heartbeat. And there's a device ID labeled to it, which has each device to it. Now, this allows them to actually see where is a drop happening. Now, this is extremely powerful because these questions can keep go drilling further and further. You could always tell, are devices facing a problem? Is it that my concurrent viewers have dropped in general because the content is bad? They could actually query it by content ID. Or they could tell, is it a particular region where I'm seeing a drop? They could also tell whether it's a particular device which is seeing a drop. They could also tell whether it's a particular platform type which is seeing a drop. Now, at that level, because this cardinality allows them to dissect that information, they were able to do this. I want to pick up another completely different example, which is noisy neighbor. Now, many of you would have already heard of this term noisy neighbor, and for others, maybe I can explain that for a moment. What they do is it's a customer which actually sends out campaigns. Now, because it's a SaaS company, and most of us are in this world of running SaaS software where there's multi-tenant, we share the same infrastructure for across customers. Every time there is a campaign being sent, now it could also be because there were other customers who were sitting on the same shared infrastructure. Resource utilization of one starts impacting the other. To be able to dissect this kind of information, what they do is they emit metrics and they start emitting different dimensionality labels with it as well, which is campaign ID, the stack ID, the region ID, or so they have a separate identifier for a farm. So that. Now the type of question, the same metric, like look at it in a way where we say HTTP request sum total itself, and we add all these fields to it. They could have different views out of it. The first view that they create is, okay, have the number of transactions gone down? Then they have another view which says, has the number of transactions gone down by customer? So now they know that is there a particular campaign which is getting impacted for a particular tenant of theirs. They could also do, and they have been, is it a particular set of infrastructure that is getting impacted because of this? And as a net result, things are slower. Now, it's not as straightforward. Look at this. There are different teams here, right? The same metric is actually being consumed by different teams. It could be the product team, which looks at this number and says, okay, one of our product features is going bad. Or it could be the customer success team, which is deriving an information out of the same metric because the cardinality is there. Because every single part of the metric may have a different interested audience as well. The customer success team could be looking at the same one and say, my X number of tenants, which I'm responsible for, is getting impacted. Or it could be the SRE team, which says, this particular region is getting impacted. Now, the same metric, because it has been enriched with such high amount of cardinality and dimensionality in it, can power multiple teams and brings them together. All this time, we all struggle for context. What we forget is this simple trick of making your metrics enrich can actually implant more and more context into all of those things and bring all those conversations together because they're all looking at the same thing. They're no longer that, infrastructure looks okay. I don't know why it's failing. Here's a metric. You improve the infrastructure, this metric will improve. The product team, the customer success team, the infrastructure team can all validate by looking at the same set of information because the source of truth is the same for all of them. Now, so if I take a rewind of it, investing into this, like the whole hoopla around cardinality, what does it really unlock? It unlocks granularity, it unlocks precision, segmentation, performance, and extremely complex context can be injected into the observability that you are deriving out of system. Let's double down on this. What does granularity mean? It could be not just payment method. Your observations are per gateway, per status, per merchant. The amount of the richness of your questions keep going deeper and deeper. You can start dissecting further and further as much as you want. Because with more answers, you can only have more questions thereafter. That, okay, I know this is working, but what else is not working? Segmentation. It's not just limited to finding problems. Think about it. If I had the same set of metrics and I was also sending labels of campaign, age, region, I could start deriving so much valuable information. Think about creating views that, okay, people who are from 18 to 25 range take only 5 seconds to complete a payment. People who are above 45 will take so much more to complete a payment, which means the threshold has to be increased, because maybe they are the ones who are paying us more. Things like that. There's so much that you can unlock because of it. Precision. You can capture fluctuations. Now, because you're going granular to a degree that you're not just observing as a whole, but as different parts of the system you could measure as well. You could say, here's a fluctuation happening on a subsystem, on a substack of this entire system, so that you can act on it faster. You can take corrective action. More importantly, it also acts as a confirmation for you to know, okay, my deployment in my canary or my AB has actually genuinely fixed this before it impacted the rest of the system. Performance evaluation. Now, here's an interesting one. We usually qualify things as just good and bad. Think about, and this is a classic example of bucketing here. But if you're emitting an information, you were earlier just emitting a success or true or false, right? Now, because something can be extremely high cardinality, you would start grading the performance as well. You would not just say a success and failure. Maybe you'll start emitting the status message as well, which goes as for buckets as well. When you emit latency, you don't just say as slow and fast. You basically grade it through. You say that 0 to 1, 1 to 5, 5 to 15, 15 to 50, 50 to 100. Maybe the grade same. This kind of evaluation of performance becomes possible as well with cardinality or complex context that we spoke about. You can actually inject an environment, a tag, a version number. It could be the same software with a different number, version number. This has actually helped us a lot as well. The same metric, but if you couple it with the version number of the software, we can instantly tell, it's the older version which is failing, it's not the newer version. If we don't deal with this cardinality, think about it, whatever we just spoke, by not dealing with this cardinality or by choosing not to emit these metrics, effectively, we are sacrificing our actionability on top of it because we don't have any knowledge about it, which means we are also sacrificing faster reaction times. We are as slow as the data that we'll get. It will be very latent. Or, in nutshell, we're actually avoiding the entire knowledge that we can derive out of the system. So, well, yeah, collectively, let's just have cardinality today. But, you know, here is where the systems start breaking. Because with so much amount of data, you need something which is where you can actually have all of this to be saved, or you can process this. This is the part where most observability systems break. And the standard question that comes up, how do you deal with this cardinality? We ran a simple post on Reddit the other day, and you'll be surprised at the most common reaction that people think that would be how to deal with cardinality. The answer that is assumed is to avoid it or go change the instrumentation. But to change that, it's a lot of effort. There has to be different and better ways to dealing with this cardinality. Let's look at the workload one more time. Here is your entire metric database. Just one second. Yeah. Here's your entire database. There is alerting pipeline running on top of it. There's a dashboard running on top of it. There are these jobs which are pulling this data constantly running on top of it. And we assume that they'll be all good, but this is how the cluster looks like. Everything is trying to query all things at the same time. Look at the poor database at the back. Trying to serve a smaller query, a larger query, a wider query, a shallow query, different kinds of queries. So, I mean, it's constantly under duress, and there's also ingestion happening on the other side, because that is how our observability databases are. It's a small database, data is being written, data is being read. So that thing is under constant duress. And imagine if that goes down, it's a blackout. Nobody gets to see anything, nobody gets to write anything. And the sad part is, for the duration at which it was down, the only purpose that it was solving was to answer failures. It itself goes down in that moment, and nobody can know anything around it. So here's what we have learned by running these systems at scale. Dimensions are only going to keep growing. It's quite natural as we went through that cycle. At no point of time would we ever say that, okay, I no longer need to know a dissection by status. I can only have more and more dimensions that I want. I cannot have less dimensions. So this is a one-way street. It is only going to keep adding. Second thing is, every time there's a new dimension added, you have to go back to the engineering team or the ones who are actually emitting the data, where the source of the information is. Now, if we are SREs, we'll go back to the engineering team and the feature engineering team and say, hey, could you also add this additional label? Hey, could you add this one more label? It's a constant to and fro. And think about it. You're not just sitting there and say, okay, I'm going to deploy this right away. In the next 1 minute, you're going to have all this information. It's going to sit on their sprint cycle. So every additional information of dimension that we desire is going to result in one sprint of a sprint. Could be a week, could be a fortnight, depending on your organization. But that's a delay in my information. If I have to take any action on it today, I have to wait for one more week so that the information starts flowing. And thereafter, when enough data is captured, is when I'll be able to take an action out of it. I anyway cannot go back in the past and ask for that additional information. So, how does this work? Usually, you go back to the engineering team and say, could you possibly add these plethora of these 10 or 20 dimensions for me so that I don't have to keep coming back at you, and we don't have to keep going through this back and forth chase. So, yeah, cool. Let me add this 20. What does that mean? It results there's always going to be a wastage. Maybe I don't need those 20 today. Maybe I only need 15. Maybe I only need 5. But with the fear that I will not have this information later, I'm going to ask for more. As a result of it, there is always going to be extra resources which are used or being wasted per se, which are not answering those extra set of questions. Lastly, different metrics have different needs. My infrastructure metrics, well, they don't, I don't need them to have such a performance guarantee to it, or they have a different scaling strategy. My business metrics are far more valuable to me, but I don't have a way to express this. And this is what we have learned across the system. When people see, and this is where they start creating lakes of a system. They say, here is a Prometheus of mine, but this is only dedicated to infrastructure. Here is a Thanos of mine, which is dedicated to long-term storage of certain other kind of need. And here is my business metric, which I actually save in a very, I well guard them because, well, product team is going to derive their knowledge out of these. So they better not go down. It may just be a separate third-party system as well, where I'm sending this crucial and this precious data to. So I've got these different lakes and these islands of information now. And then what happens? Post after that, as these data grows, the silos become, each silo becomes a sinkhole of itself, and there is no way to converse this data thereafter as well. Well, there is, but then there's another team which is building another lake, which is a unified lake out of this, So how does it start? We start with one piece of software, different lakes of observability. Then there's a separate team which will combine this data and say, here's a data engineering platform where we have observability lake or the bedrock of intelligence. So pretty needless if you look at it, right? And what are these wrong choices that we have made in this battle with cardinality here? Let's pick up the three choices. And this is all of us go through this decision. We go through this and we realize we're going to start with buying it out. We buy the most expensive infinite storage system. The other could be, Here one. Let's go the completely other way around. Let's start building this in-house. I'm gonna build an entire observability platform in-house. I'll use Prometheus, I'll use some other open source system, or alternatively, let's have certain workflows which allow managing high cardinality metrics. And we believe the answer here is actually in these smart workflows. So what are these workflows? But before we get to that, it's very important to know the life cycle of a metric. Now, here's a life cycle of a metric as we define it. It starts with an instrumentation. The next layer of it is an ingestion layer. The next layer of it is a storage layer. And next is a querying layer. Instrumentation means basically changing your application code, where you would say, I'm going to install a Prometheus library in my Golang code, or I'm going to use an hotel compatible library. I'm going to use a micrometer, stuff like this. It's basically a way for you to emit the metric and land it into a transport so that it can reach another system. Then there'll be an ingestion system. Ingestion system would be, I'm going to push this data to a XYZ agent, or I'm going to use a remote write, I'm going to use an hotel collector pipeline, etc. And then it lands into the storage part. In the storage part, you would do something with the metric. There'll be things like you will change the retention of it, you will probably perform a roll up on it, or you would save copies of it in a replication factor. And then there's a querying phase. The same metric would now show up while you're alerting, you're creating dashboards, or you're creating SLOs. Now, if you look at this, what are the two wrong places and the two right places where cardinality can be dealt? The first one and the last one are the wrong places. Why so? Because if I have to go back and alter the cardinality, let's say if I got extra cardinality, somebody accidentally injected a URL in the metric in the metrics that they're emitting, it's going to result in an explosion. My only way would be to go back to the team and say, hey, in the next week, could you, in the next sprint, whenever, could you roll out a fix which doesn't send this URL? What happens during this period? I'm actually saving all of this data into my observability database. That poor database, which is getting constantly hammered by more and more data and getting slower and slower. And there's no way I can then fix this 7 days or this entire sprint worth of garbage that I've collected. It's too late. Or if I have to go back to the team, to the instrumentation phase for every additional dimensionality do I need, at times it could be too early as well, or it could be too involved as well for that matter. I could go back to them and say, every time, every sprint, one more metric, one more dimension, one more dimension. It's the most, it's the most tiring stage at which we can indulge with them. Or we go complete opposite way around. We start handling cardinality only at querying time, which means it has passed through the ingestion, it has passed through the storage, which means there is a bedrock where terabytes or petabytes of data is sitting. I'm only filtering at the time of querying. It's too late and too expensive because every single query, I'm effectively saying, I'm going to save everything, garbage, which I may never need, or stuff that is accidental as well. I'm only choosing not to see it. That's the querying stage of it, effectively, right? Which means that your storage engine and your query engine still has to go through those piles and mountains of data and find that knowledge for you. It's too late. The best phase to handle cardinality is to have workflows which sit right in the middle, in the ingestion phase and in the storage phase. What do these workflows look like? It could be an in-flight aggregation. In-flight aggregation would be as the stream of metrics comes in, it has all that rich cardinality into it, but I'm choosing, I only want to create 10 materialized views out of this. Take this data, don't save it into the database as it is, but create these views. Create a view of, say, metric by payment type, fan out. Same metric, say, create now additional metric by age, metric by gateway, metric by status method. This ability to fan out here is a great way to deal with cardinality. Or you could have cardinality limiters as well, which says if accidentally the cardinality goes beyond this point, which is accidental, only entertain 3 million. from this metric for a minute. If it goes above, just cut it off, or send the overflow to something which I don't have to use. Or at the same time, being able to explore this isolation as well to understand, oh, this is where cardinality explosion is happening. Or on the storage side, what if you had a different way of saving this cardinality, like saying all high cardinality data, which is above X amount of metric volume, will go into a cold store, whereas anything which is lesser than this for this metric type, for let me make it more practical. All metrics, the if I take the same view of it, view by payment method, all of this goes into the hot tier. Something which is fast can give me quick answers. But any dissection of infrastructure layer, that can sit in a cold layer, because that is anywhere dashboard somewhere. I don't have to set real-time alerts on it, etc. Or it could be the retention as well. X amount of metrics, infrastructure metrics, cube state metrics. I don't need them for longer than 20 days. But my performance of my application or my business or number of concurrent viewers, that I want for a year long history as well. I want to know what the last tournament looked like, what the new tournament looks like before I make any scale out plan. One of the use cases could be capacity planning, forecasting, as we spoke about that. What if I want to take a bet today? Oh, last year, when we had a similar amount of marketing expenditure, we expected 40 million concurrent viewers. This year, we're going to up the marketing expenditure because we want more. So we are expecting 60 million concurrent viewers. Now, at 40 million concurrent viewers, this is the amount of latency and the infrastructure that we needed. What do we need today? To find this answer, I must have a very large retention period of my metric. So each different kind of information could actually be saved differently as well. Now, this middle section is the best place where these workflows have to be invented, and they can help you deal with massive amount of cardinality as well. This is exactly why we built Levitate. Levitate by Last9. It's a fully managed, high cardinality, open telemetry compatible, Prometheus compatible time series data warehouse, which have all of these workflows embedded into it from the moment go. So you don't have to spend time struggling with it, and all of these workflows are a part of it. It's as simple as daylight. Anything that you have as open metrics or open telemetry compatible, all you need to do is just change the remote write endpoint. It's using the Prometheus API. It starts sending data to us, and then you can use your standard Grafana alert managers or even the Last9 UI for it, which is pretty nifty in terms of its alerting. And you can use that to combat these daily needs of observability. uh, Full metric lifecycle management, which includes streaming aggregations, cardinality controllers, flow controllers, data tiering, everything that we spoke about, or even access control policies to say who can access what part of the layer and what part of tier to what depth of query. Uh, Three simple steps: update your remote write, use Levitate, unlock time and money. Because here's a simple question that we raise to everybody. Once this cardinality is not a problem, what would you do with your metrics? What kind of questions can you start answering? What kind of observability can you start unlocking? Yeah, thank you.
Awesome. Thanks, Piyush. There are a couple of questions on the chat. Uh, One from Kumar about his comment is basically observability costs increase with cardinality. And as we try to cope up with the cost, we either have to sacrifice some of the dimensions labels of the metrics. Is there a thumb rule out of experience to define which particular dimension can be sacrificed? And how would one judge the same? Um, I think you answered this question later in the talk, but any thoughts on this?
Yeah, I mean, I'm going to wear two hats. One is assuming I don't have Levitate with me, and the other assuming I have Levitate with me, or these workflows. Uh, Depending on who the audience of the metric is, there are different teams which require different kind of answerability out of it. So, what label can you sacrifice in a metric is actually tough. Is a tough question, and in general, Yeah, so there's no thumb rule to say, this is one label that you can really just sacrifice. I would say one label that you would probably sacrifice is the one that you're not using. So if you had a way of inspecting your workloads to understand this is a dimension that I don't use at all, which means you really need to go through all your queries, etc., to understand. I never do a buy, or a pivot table on, let's say, version number. Let's drop it. Or I never do a per section dissection based on, uh, I would say, target path of my load balancer. So I can drop target path, things like these. But you'll be surprised that uh, dropping a label in a metric can actually result in negative things, because suddenly something that was unique, think about it, metric A by each target type from a load balancer, right? So load balancer is sending a request to an upstream. Upstream A, 10 requests, upstream B, 10 requests. Now you say that I don't use upstream at all, let me drop it. It becomes a duplicate metric, right? So effectively, it is number of requests 10 and number of requests 15. Now, any database would actually see them as duplicate and drop one of them. So dropping a label is one of the sounds like an easy option to deal with cardinality, but it actually has inverse effect on it. Your calculations will completely go wrong because your data will no longer be correct. So sadly, that is not the advised way as well, and there's no golden rule around it as well. Now, the right way to deal this would be that, like, which is why we actually did Levitate as well, was what if I could save this data differently? I say that I'm going to create a different aggregation out of this and say this newer resultant metric goes sits on the premium tier, and the rest of it can actually go sit on the cold and the slow performance tier, so that the cost of saving this data or this retention becomes relatively marginal. Like I don't have to spend top dollars to for every piece of information of mine. Does that kind of answer?
Right. Kumar, feel free to post in the chat. Um Also, we have a question from Amartya about how Last9 is solving the cardinality challenges. Can you throw some light on that?
Was this before I spoke about those workflows or after I spoke about those workflows?
This was 2 minutes ago.
Oh, this
So
was two
after
minutes
you
ago.
spoke about the workflows.
Oh, okay,
Yeah.
all right. So, who is the question from? Could you mention that?
Amartya.
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 Yeah, yeah. Hey, Amartya. So fundamentally at the helm of it, I would say that the secret sauce is being able to identify each series as separate and being able to save them on different tiers of data. This is not a new concept. If you look at the worlds of Hadoop and data processing, right? As we say, uh, all of this is actually inspired from what data engineering teams have done to transactional and relational data in the past. If you tell this to a Hadoop guy, they'll say, yeah, that's easy. I'm going to create a cold tier, a warm tier, a hot tier. I'm going to start saving this data accordingly, right? I think that is a fundamental secret sauce. The secret sauce is to not save less data. And it's also not, coming up with a new storage in a disk pattern. No? The secret sauce is how do you categorize or triage information as important, precious, instant. There are these different categories of it, and I'm taking various ways of categorization of data. This part of data is not important to me, this part of data is less important to me. So that's part number one. Part number two is stream processing, basically being able to actually look at high volume streams of data and being able to process them in real time so that they can be saved in their different destinations or their nature can be changed. Like, and this is like anybody who has used Kafka or Hadoop systems in the past, very similar things have been done in data world on that as well, just that these constructs have been missing on time series systems. So with Levitate we actually brought the same concept of tiered storage and stream processing into a time series data warehouse. Does that answer, Amartya? I mean, it's a fairly technical, and I'm very happy to take a separate section. Maybe we can exchange our handles and we can go deeper into this. We also have a white paper, by the way, which actually
Yeah.
covers a lot of the under the hood things behind this. and principles that encouraged us to build why we have built the way we have built it.
Yeah, I have shared the white paper link on the chat. Amartya, feel free to comment, and we'll also reach out to you if needed for more detailed discussion. Piyush, I had a question that somebody had asked on Discord, where somebody will try running into these cardinality challenges in their journey. Uh, would you like to address that? Like at what
Ah,
stage of the organization or at what stage these problems starts mattering more than at other stages?
yeah, interesting, because the I would say at a stage when degradation starts becoming a matter of concern. At as a young startup, every alert is important to us. Because I remember my first startup, and uh, until we had 40 or 50 customers, we knew their names, by their handles. So you could tell that, oh, that customer is paying, that customer is paying, and at that point of time, everything was important to us, right? So beyond that point, you reach a point where there are invisible losses that start happening to the business. You cannot be large enough to track everything, but you are substantial enough where you want to minimize them. And this is a very tipping point. What I'm saying is, effectively, a way to decipher this is, you are no longer 100% up and available, but you also don't want to be available any less than 99.9. Does it make sense? Like you reach that kind of tipping point that I know I cannot do this, like every request can be served, but at the same time, I want to minimize my losses. And that is a moment when teams usually start investing in this observability. Because, prior to that, how do you find this question? Well, every engineer is their eyes glued to the screen. So you don't need observability because engineers are doing it for you, you know and but then comes a point where you want some system to do this for you, and for that you want that entire signal, telemetry, health to be saved in a way where it can be processed while you are not watching the screens to constantly look for losses. And that is a time when you start dealing with this. Is that a fair reference? Otherwise, does it give an relatively more
Yeah,
tangible journey? Okay, cool.
yeah, definitely. And I think also it talks about the stages an organization itself goes in terms of their growth as well, in terms of how they scale in customers or in just the growth of the company as well. So I think that answers the question very well. I have also shared a blog post from Piyush in the chat about difference between samples, metrics, and cardinality. Like that will give a very good idea about the differentiation between what a sample is, metric is, cardinality is. If you're new to the time series terminologies, I have one last question that somebody had asked. Who did all the like the caricatures and the sketches in your slides, Piyush?
Oh, I did those.
Oh, awesome. I
Yeah.
think, yeah, that is a very interesting part of the slide deck, so people liked it.
Oh, yeah. Get on a flight where you don't have internet. That's the only way you'll do those presentations.
Awesome. Yeah, we know how much you travel these days. All right, I think if no more questions, we can wrap up. I'll share the notes as well
I
as
see some
the
in these
slides.
comments. I see some questions in the comments, Prathamesh, on this chat. There's one from Nachiket. Does the performance to capture the cardinality by increasing the number of things that are captured? Oh, you already answered that. Okay, cool. All right.
Yeah.
Okay, cool. Got it.
Yeah, Amartya has a comment just now. Your view about saving the data in different tier is great, but then also it is charging us. Grafana is giving adaptive metrics where they are suggesting which all dimensions can be dropped.
Oh, we do that, Amartya. That's an easy one. We took the harder one route, and you'd be surprised at the a lot of like these. Like the standard ones, dropping, relabeling, etc. Those are things that all platforms offer. We do that as well. We do over and above that, right? Imagine if I say you didn't have to save this data, all of it, right? You didn't have to drop as well. Think about this way. Now, every single dashboard that you create is basically an aggregation query set, an information that you want, which is being served every time from data that you're saving. What if somebody came and said, each of these queries can actually be saved as it is? Remember, in databases, we have thing called materialized views, right? Now imagine if you could create those as well. Effectively, you got tons of data, but you're literally being charged for thousands of data, right? So we go over and above that. We don't want you to sacrifice the data. Relabeling, dropping, these are very cheap and convenient options, but they also result in huge loss of information. Everything that we try to present here is to say, go over and above that, tackle the problem upfront, right? Without having to worry about it. I mean, I understand the cost is a concern, and I would actually like to have a follow-up chat with you because, we do believe that we've been able to send a lot of this benefits of this technology push to our customers, like so that you don't have to make those inferior choices. Yeah.
Yep. Um, Amrish has a question. How Levitate is different from Victoria logs? Amrish, did you mean Victoria metrics? Because Victoria logs is all about logs, and Levitate is a metrics time series data warehouse. But Piyush, we can assume it is Victoria metrics and
We
take
can
it
take
ahead.
both. One answer you've already done.
Yeah.
That is different. From Victoria Metrics, Amrish, the same construct of a warehouse being different from just a database because the database will only save data. When you add the muscle of a warehouse to it, you're basically adding things like like separation of read path and write path. What that means is uh, if there's any degradation or if there's any strain on the read, one of the storage tiers. Think about it, right? Let's say there is one bad query which is accessing in a year worth of data every 30 seconds. You as a DBA now would say this token will always read from cold tier. The very simple. I'm not saying this is the only differentiator, but think about this as a differentiator right now. This very simple switch that you made of traffic shaping, what this allows is your rights are never going to be sacrificed. Second, your alerting is never going to get slow. The guarantee, this isolation, these workflows that come additionally on top of it, which are in the life cycle of a database thereafter. What a DBA or a system administrator or an SRE would have to then do to design a robust, resilient system are inbuilt right into Levitate from day one. And this is one of the many differences. Uh, I mean, I'm happy to have a follow-up chat with you, Amrish. I know you from LinkedIn. You're very, yeah, I mean, your questions are really commendable. Yeah, I would have to love those to hear those more in detail as well.
Piyush, there is one more question from Discord about uh, how do we identify these high cardinality metrics before taking the decision about the streaming aggregation or not having a streaming aggregation?
Oh, okay. So we have I mean, again, limited answer, non-limited answer. Uh, limited, non-limited answer. You let it sit into the database. You know which one's breaking. You do a careful inspection of how many series per that. Now, here's a tricky part because if the database cannot serve at that cardinality, it probably won't answer this question very fast as well. And but it's possible. I'm not going to say it's not possible. If you have ample time, you can run a query for an hour and get the answer. Now the levitate part of it, well, we do have a direct cardinality alerts, which actually go through these stages of certain heuristic to say here is a metric which may be hitting a very high cardinality alert. Second, here's a metric which has hit high cardinality alert. So it goes through those stages of progressions, and we have fairly sophisticated live counters which basically can actually count across these large set of metrics, the series counters, etc. as well. Yeah.
Perfect. I think we are almost out of time. So we'll wrap up. If there are any more questions, I'll handle them offline. And feel free to reach out to me or Piyush directly on LinkedIn if you want to know more about Levitate or want to see it in action. Would love to showcase that. Additionally, I'll post a link about how to get started as well, because you can just start sending the data and test some of these capabilities as well. It's extremely easy to get started. Thanks, Piyush, and thanks everyone for um, attending the session, and we really appreciate it. Hopefully, I think this talk has sparked some curiosity about cardinality and its challenges, and I think that will help everyone in the ecosystem in terms of how to think about some of these cardinality related challenges from the ground up. So, thanks everyone, and we'll stop the recording now. Thank you.
Thank you, everybody. Thanks, Prathamesh. Bye.